Hello friends, welcome to this video. Here in this video we shall discuss about projectile motion. Okay. What is a projectile motion? And we will also learn about some terms related to this projectile motion, and we will derive mathematically the values of those terms. Okay. So projectile motion is what is a projectile motion? So suppose it's a you throw something. Okay, suppose you are standing here. Okay, you are standing here and you throw something. So what happens? This object will follow a path like this. Okay, some type of parabolic path. This is not a very good drawing. Let me just redraw it. So suppose you throw something. Okay, so this object will move like this and fall. Okay, or you throw maybe even to a greater height, so something like this, it moves like this and finally it falls. So this type of, so the thing which you throw is called a projectile. Okay, and the three thing which you throw upwards is called a projectile, and the motion which is followed by this projectile. Okay, the motion of this object called projectile is actually the projectile motion. Okay, so is there any characteristic of projectile motions? So I mean, what is the characteristic of motion of such a projectile? So when we talk about this term projectile motion, in that case the only force, it is assumed that the only force which acts on the object is nothing but the gravitational force. Okay, the gravitational force is the only force acting on the object. But with this said, it doesn't mean that other forces are not acting on the object. Okay, like when you throw something into air, so maybe air resistance is there, or air friction force is there. But for projectile motions, we consider only gravitational force. Okay, so we don't consider other types of forces which may be acting on that object. Okay, so projectile motion is okay. Let me try to draw a better parabola. Suppose you throw something. Okay, you throw an object and it okay, let me try to draw it better. Okay, something like this. Maybe it goes to a certain height, certain distance, and again falls to the ground. Okay, this is the ground. Okay, so you start from here and the object falls on the ground. Okay, so this is this parabolic shape is the path of a projectile. Okay, so now there are three things we will three terms related to projectile motion we have to understand, and consequently we will calculate their numerical values. One of those terms is the called the time of flight. Okay, time of flight. So what does this time of flight means? Time of flight means for how long the object will remain in air, or not in air, for how long the object will travel. You have suppose the object you have thrown here, the object started here and it has arrived here. So for how long this object has traveled and reached its final destination, that is called the time of flight. Okay, the second time that we have to know or we will calculate is maximum height. Okay, maximum height. And I hope from this maximum height time itself we have understood that how much what is the maximum height attained by the projectile during the course of its motion. Okay, this is the ground and this is the maximum height. Okay, this line it represents the maximum height. And another term which we will have to calculate for a which you have to understand for a projectile motion is the horizontal range. Okay, horizontal range. What does horizontal range mean? So horizontally, how much distance has been traveled by the projectile? Okay, the projectile started here and it reaches this point. Maybe A, B. Okay, I give this point name A and give this point name B. So how much distance it has traveled along, traveled horizontally? Okay, so that is the horizontal range. So these three terms about projectile motion we have to understand. Okay, so let us first start with the term time of flight. Okay, time of flight. Time of flight. So how would we calculate? So this term called time of flight. Okay. So already you have defined time of flight. So for how long or for what time duration the object is moving. Okay. The projectile has been traveling. That is the time of flight. Okay. So in order to find these various quantities, let me just write down the equations that we will use. Okay. So the equations of motions are the ones that we shall have to use. So what are those equations of motions? The equations of motions are like this. V, okay. V, sorry, let me rewrite. This as, okay. So it's V equal to U minus GT. Okay. This is one equation of motion. Another equation of motion is this one, S equal to ut minus half gt square. Okay, and the third equation of motion is v square equal to u square minus twice gh. Okay, so you see that the acceleration term, okay, so acceleration term a has been replaced with the gravitational acceleration due to gravity term. Okay, so we are not considering normal acceleration, but we are considering the acceleration due to gravity, because we already defined that only the gravitational force is the force which acts on a projectile during the course of its motion. Okay, therefore instead of normal acceleration we will consider the acceleration due to gravity. So basically we can find this terms from these equations. Okay, so let us consider, I have so for reference we have written down these equations here, and then we will calculate our required quantities. Okay, so time of flight. Okay, how we can find it? Okay, okay, so before we calculate time of flight, let me discuss something here. So the object moves from point A to, suppose, point C. Okay, and then it falls down and reaches point B. So what is the distance? So in practice, the object has basically moved horizontally. Okay, although it was thrown up vertically, but finally it reaches the ground. So practically, the object moves a horizontal distance. Okay, so then what is the vertical distance moved by the object? So the vertical distance moved by the object is equal to 0. Okay, why 0? Because the object has moved just horizontally, because at the end of its motion it is at the point B. Okay, so point B is on the ground, so it is so its motion can just be considered to be horizontal. Okay, vertically its distance traveled is equal to 0. Okay, so vertically means along y-axis. Along y-axis, if we consider x and y-axis, so if this is horizontally x-axis, vertically y-axis, so horizontally along y-axis, its distance traveled is 0. So again, suppose the projectile is object is projected with a velocity of sorry, let me wrap this for better representation. Suppose the projectile is it is the object is projected with a velocity of suppose u. Okay, so what is the horizontal component of velocity? Okay, the projectile is projected with a velocity u that makes an angle theta with the horizontal. Okay, so makes an angle theta with the horizontal. So what is the horizontal component of velocity? That is u cos theta. What is the vertical component of velocity? The vertical component of velocity is equal to u sine theta. Okay. So along x-axis, the velocity component is u cos theta, u cos theta. Along y-axis or vertically, the velocity component is u sine theta. Okay, so very important to note this point is because velocity is a vector quantity and we can resolve a velocity along x and y axis. Okay, so okay, so let's come back to our topic, time of flight. So vertically, the distance moved by the object is zero. Okay, so but what is the vertical component of velocity? Okay, so let me just write down the equation for better understanding. S equal to ut minus half g t square. Okay, so s equal to 0 along y-axis. So u is the y component velocity. So that is u sine theta. Okay, we write u sine theta multiplied by t minus half g t square. Okay, that is how we can write this expression now for the motion of the object along y-axis. So let me rearrange this equation. U sin theta multiplied by t equal to half g t square. Okay, so we have to calculate the value of t from this equation, and that would give us the time of flight. Okay, so t, if we cancel, one t will be remaining. So t will be equal to twice u sin theta over g, twice u sine theta over g. Okay, so this is the expression for time of flight. So that means the projectile will be in motion for this much time, twice u sine theta by g. Okay, so remember that in order to calculate the time of flight, we have to consider the motion of the object along the y-axis. Okay, so that makes our calculation easy. Along the y-axis or vertically, the resultant motion of the object is zero. I mean, it has zero displacement, so that we have to consider, and with that consideration we can calculate the time of flight like this. Okay, so this expression is done. Time of flight. Now let us calculate maximum height. How much is the height attained by the projectile during the course of its motion? So it's basically, let us consider this equation now. V square equal to u square minus twice gh. Since we are again considering the height of the object, okay, maximum height of the projectile or the object. So height means in order to calculate the height, we have to again go vertically. Okay, we have to again consider the vertical motion of the object. Again consider the vertical motion of the object. So what at the maximum height? Okay, at the maximum height here at the point C, what is the velocity of this object? It is zero, because the object temporarily comes to at rest, the projectile temporarily comes to at rest, and since its velocity is equal to zero. So how we can write this equation? So 0, okay, v square equal to 0, u square. Okay, so u means basically what is the velocity of the object along the vertical direction. Okay, so vertical component of velocity is this one, u sin theta. Okay, we have also shown it here, same thing. So vertical component of velocity is u sin theta whole square minus twice g h, but now I will write it simply as h max. Okay, since we are talking about maximum height, so h max is what we will write. Okay, so from here, can we calculate h max? What is the maximum height obtained by the object? Just we have to simplify this equation, simplify and rearrange. that gives us u square sine square theta over twice g. Okay, so maximum height attained by the object is given by this expression. Okay, h max is equal to u square sine square theta over 2g. Okay, so this expression is u simply. So again, in order to calculate the maximum height attained by the object, we have to consider the vertical motion, and at the highest point, the velocity of the object is zero. Therefore, considering that and considering the velocity value of the object vertically, u sin theta, we can calculate the maximum height attained by the projectile during the course of its motion. Okay, so you have also calculated maximum height. Now one last term we have to calculate, that is the horizontal range. Okay, horizontal range. So what is horizontal range? As it is quite evident from the name, that is how much distance has been traveled by the object horizontally. Okay, horizontally means a to b. Okay, so while we calculate horizontal range, suppose it is, let us assume that it is represented by r. Okay, range is r for range. Okay, so what is distance? Distance formula is distance is equal to velocity multiplied by time. Velocity multiplied by time. Very well known relation. Okay, so r equal to velocity. What velocity we have to consider now? We have to consider the horizontal velocity. Okay, since we are talking about horizontal range, so in this velocity we have to write the value of horizontal velocity of the projectile multiplied by time. Which time we have to consider now? We have to consider this time of flight, twice u sin theta over g. Okay, twice u sin theta over g. Okay, so let me just calculate and rearrange. What we get, u square. Okay, twice u square sine theta cos theta over g. Okay, so horizontal range is twice u square sine theta cos theta by g. So u square and twice sine theta cos theta, that can be written as sine twice theta over g. Okay, because sine in from trigonometry, sine twice theta is equal to twice sine theta cos theta. Okay, cos theta. So basically this gives us the value of the horizontal range. Okay, so r equal to u square sine twice theta over g. Okay, so yeah, so again, in order to calculate the horizontal range, as the name suggests, you have to consider the horizontal velocity, which is u cos theta multiplied by the time. Time means this time of flight, for how much time the object has been in motion. That time of flight was already calculated earlier, twice u sin theta over g. So simplify, so we will basically get u square sine twice theta over g. Okay, so these three are the relations, these three are the terms related to a projectile motion we had to understand, and we had to calculate their values. So yes, so you can calculate these various quantities: time of flight, maximum height attained, and horizontal range, like this. So friends, I hope you have understood the topic, and if you have any questions, please post in the comment section. And thank you very much for watching this video. I will see you soon in the next video. So thank you very much.